Hello there, and welcome to Logarithms and Natural Logs. Fortunately for all of you, this first video is going to go over the conversion between an exponential function to a logarithmic function. Now keep in mind that when you're doing this conversion, this is essential for all logarithmic mathematics. So the first thing we want to start covering is, what is an exponential? What does that graph look like? Well, let's take a look at one. So an exponential graph has this awkward looking curve, and it's called an exponential because we have an x sitting right there in the exponent. You can't miss it. So if there's an x in the exponent, you have an exponential. Great. There's two unique values that are included within exponentials, and one of the first ones is the y-intercept, which means that a number raised to the 0 power, whether it's 2, 3, 4, or 5, will always equal 1. Unless, of course, you're dealing with 0 to the 0. That just does some funky stuff that we're not going to talk about until you hit calculus. But it also has a horizontal asymptote, which some people refer to as HA, but it's a horizontal asymptote. It gets really close to y equals 0, but it's never going to equal 0. Therefore, the second property, 2 raised to the x power, cannot equal 0. It'll get close to it, but it'll never equal it. So that being said, hello there, tall guy. Let's see here. Let's do a little bit of exponential math just to get you jump-started again. Now keep in mind, a lot of this is going to seem really easy, and this is going to be a quick refresher, but it's nice to keep this level of refreshing. So let's see here what we said in the last video. 2 raised to the 0 power is 1, and 2 raised to the first power is 2. Okay, that's positive exponents. We've all done these left and right. Let's see what happens when we do negatives. Wait a minute here. How'd that turn into a half? When you're dealing with negative exponents, you have to deal with something called the reciprocal. So you flip this number over, and what you get is 1 over 2 to the second power, which is essentially then 1 over 4. Haha. Still with me? I hope so. So what if I'm not dealing with nice numbers? What if I want to deal with, something that looks like this particular equation in front of you? And this is a common problem in the remedial mathematics, where they'll say, okay, 2 raised to a number equals 2. Okay, nothing wrong with that. We just did that in the last board. So 2 raised to a number equals 2, therefore that number has to equal 1. Well, that's fine and dandy and all, but why do we even need to know this level of mathematics? What's the point of logarithms, and why am I going over exponentials so deeply? Because if you're dealing with logarithms, then you could be dealing with a base of any real number. Doesn't have to be a pre-number, it doesn't have to be 2, it could be 3 million, it could be 1/2, it could be a quarter. So we're going to refer to this b as the base. This x is obviously your exponent, no pun intended. And this y, well, we're going to consider that to be an output for just the moment, just something to let us know that this is the answer. All right? So we have our base, our exponent, and our output. Now, if I wanted to convert an exponential to a log using the same variables, of course, well, then we come out with this nice looking conversion factor. How important is this particular conversion? It is very important, because this is one of the only ways to convert an exponential straight off into a logarithm. So how well do you have to know this conversion? Very. You have to know it very well to keep up with the rest of the videos. So we're going to do a couple of quick practices just to get you jump started. So 2 raised to the second power is 4. Therefore, alrighty then. And again, keep in mind, this is still b to the x equals y. Therefore, log of some by equals x. I'm just going to make that capitalized to keep for consistency. And again, we're just going to look at a couple more, nothing too fancy or out of the ordinary, just something to keep us going with the practice. And if you're not coming up with these same answers, go back to the previous board and write down that conversion factor over and over again. So it's not uncommon for teachers to ask you to convert between the two items, but more importantly, calculators can do logarithms much more effectively than they can do exponents. But calculators tend to say just log. There's nothing wrong with that. A log just means that you're dealing with log of base 10. Okay? So don't panic if I don't write log base 4 or 3 or 2. If I just say log, what I'm really referring to is just log base 10. And that's what calculators like to deal with. Everybody with me so far? Excellent. So that's it for this video, and we're going to go off and talk a little bit more about some of the properties of logarithms in the next slide, or actually the next video now that I think about it. Yeah, it's just the next video. But we're going to talk a little bit more about some of their properties. So the addition of logarithms, the subtraction of logarithms, why do we use these particular conversions back and forth? So just as a quick reminder, if I give you a base to an exponent equals y, then you should know to convert this to log of some base y equals x. And you have to know how to go back and forth on this, otherwise you're going to struggle a lot when it comes down to logarithms. See y'all next time.